Hello, everyone. What we'd like to talk about in this in this lecture here, are some famous trig identities. Now, this is the first time you're going to be seeing these, but these come up all the time in this class, in calculus, and for many of you, for many students, I think students memorize a lot of this stuff here. I'm terrible at memorizing things, so what I would like to do is give you some tricks on remembering these trig identities and really have you understand where they come from. Okay, so there's a series of trig identities we're going to talk about. I guess the first ones that we've already talked about are what's called the reciprocal identities. Now this just come from the definition of sine, cosine, and tangent. So we have what's called the reciprocal identities, which we've already been working with, but I think it's good just to write them down again. So in this case here, we have that the cosecant of t, instead of putting a t here, you could equivalently put a theta. So cosecant, remember, is the reciprocal of sine. So this is 1 over sine of t. Or equivalently, that sine of t is the same thing as 1 over cosecant of t. Okay, kind of put these ones here together. We also have that secant of theta. This is the reciprocal of cosine. So this is 1 over the cosine of t. I know I put a theta here. You could put thetas or t's, it's fine. T. And similarly, cosine of t is 1 over secant of t. And the last reciprocal identity is, or I guess there's two more. I guess there's three more I'm going to write up. So we also have that the cotangent of t, cotangent is a reciprocal of tangent, so 1 over the tangent of t. So this also means that the tangent of t is equivalent to 1 over the cotangent of t. Okay. But we discovered another trig identity in the past lecture, tangent. We also have that tangent of t is equivalent to the sine of t over the cosine of t. It says saying that tangent is the same thing as that line on the unit circle. Whenever I'm thinking about tangent, I always think about all trig functions just in terms of sines and cosines. Any trig function you can write in terms of either sines or cosines. Tangent is the same as sine over cosine. But since cotangent is the reciprocal of tangent, we also have, we'll put these together, that cotangent of t is the same as cosine of t over the sine of t. So these are what we call the reciprocal identities. And what's great is we can write any trig function in terms of sines and cosines. It'll be something very useful, something we're going to want to keep in our mathematical tool belt. Okay, now let's get to the Pythagorean identities. And I'll explain why they're called the Pythagorean identities. Don't forget these. Pythagorean identities. Okay, recall the unit circle. We have a circle. It has a radius of 1. This is the x-coordinate, and this here is the y-coordinate. We have x and y. Now what's true about the unit circle is, so you have this triangle, we have that the Pythagorean theorem holds, that x squared plus y squared is equal to 1 squared. We have that x squared plus y squared is equal to 1. But on the other hand, what we learned is, since sine is opposite over hypotenuse, sine, because if we rotate an angle theta, or you could think t if you like, rotating an angle theta, traveling along the distance of the unit circle, a value of t the same, theta and t will be the same. that sine is opposite over hypotenuse, so sine is the y coordinate. So here, this distance here is sine of t, and this would be cosine of t, or theta if you'd like. So this is cosine of t and sine of t. Okay, so over here we have that x squared plus y squared is 1. So here we get our first trig identity. Notice here that x is the same thing as cosine of t, and y is the same thing as sine of t. So inputting those in there, inputting cosine for x and sine for y, we get that cosine of t squared plus sine of t squared is equal to 1. Now, oftentimes when we square trig functions, it's very common to not write the 2 here. We oftentimes move the 2 here. So we would equivalently write cosine squared of t. This is just a convention. When I see a cosine with a 2 here, that means cosine times cosine. If there was a 3 here, it'd be cosine times cosine times cosine. Plus sine squared of t is equal to 1. And here's one of the most famous trig identities, the Pythagorean identity. It's true that cosine squared plus sine squared is 1. Now this is really one of the only trig identities that really fully makes sense to me, because really what this is just saying is the Pythagorean theorem on the unit circle, and that's how we get the name the Pythagorean identities. So let's write that up, and then we'll get the other two. So for whatever reason in my head, I know cosine squared plus sine squared is 1, but order of addition is commutative. So for whatever reason, I always like writing sine squared of t plus cosine squared of t is equal to 1. Sine squared plus cosine squared is 1. Okay, this is our first Pythagorean identity. Now there's 2 more. Now, you'll find that there's going to be a lot of trig identities in this class, but I really made it through all of grad school really just knowing the reciprocal identities and that sine squared plus cosine squared is 1. Okay, how am I going to get the other ones? I'm going to get the other ones by just massaging this. I'm going to divide both sides by either sine squared or cosine squared. Let's first divide both sides by cosine squared. So if I divide both sides by cosine squared, distribute to each piece, so since exponents distribute through division, mainly that if I have x over y squared, this is the same thing as x squared over y squared. So this is all equivalent to me writing in parentheses sine of t over cosine of t quantity squared plus, well, cosine squared over sine squared, that's just 1. Is going to be equal to, you could think of this 1 as being 1 squared. So this will just be 1 over cosine squared, or cosine of t, all being squared. Well, what's sine over cosine? That's tangent. So this is tangent of t squared plus 1. 1 over cosine, that's secant squared. So what do we have? We have that tangent squared of t plus 1 is equal to secant squared of t. And here we have it, our second Pythagorean identity. Okay, let's do the next one. I'll write them all up here in just a second, but I want to derive one more. So why don't I just write this up right here? What we have is we have that tangent squared of t plus 1 is secant squared of t. Okay, how am I going to get the other Pythagorean identity? Well, instead of dividing both sides by what we did last time, cosine squared, how about we divide both sides by sine squared? So in this case, we'll have sine squared over sine squared, that's just 1, plus this will be cosine squared over sine squared. Cosine over sine is cotangent. This will be cotangent squared of t is equal to, this is 1 over sine squared, 1 over sine is cosecant. This will be equal to cosecant squared of t. And here we have it, the 3 Pythagorean identities. First one. Now, again, what do? I have the first one memorized. This one makes sense to me because it's just the Pythagorean theorem on the unit circle. These other two I derive directly from this one. Less memorization. If I know where things come from, it helps me understand the material rather than memorizing. So 1, 2, and 3. Another thing, maybe we won't be using as much in this class, but this will help many of you hopefully in Calc 2 when you have to remember these things called derivatives. I remember that certain functions are good friends with one another. Sine and cosine are good friends. Tangent and secant are buddies. They're good friends. And cotangent and cosecant are good friends. This is going to be something that'll hopefully help you in in calculus when you have to remember what's called the derivatives of these functions. But that's for next quarter. That's all I have for you for this lecture. We'll see you in the next one.